Hello, welcome to fractions. We're going to do some more with fractions. This time we're going to simplify and complexify. Now I made up the word complexify for my use. I'm sure other people have used something similar for this, but this is how to change fractions back and forth. Let's start with there are two major ideas. Those major ideas include multiplication by 1, and the other one is how many different ways you can write the number 1. So let's look at these. Number 1, 6 times 1 equals, hey, that's 6. What's 5 times 1? That's 5. What's 7,238 times 1? Hey, that's 7,238. You remember the wonderful time you had when you go back home to your mom and say, hey mom, go ahead and ask me all my 1 times tables. I got them down. Oh yeah, what's 3,948 times 1? Hey, it's 3,948. I know all of my 1 times tables. A number timesing by 1 always remains the exact same number. Now let's look at this other idea. 1. 1 is the same as 10 over 10. 5 over 5. 5 divided by 5 is 1. 6 over 6. 7 over 7. 3 over 3. 3,948. All over 3,948. All of these are just different names for the number 1, even though they look differently. So now let's put these two ideas together and see what we come up with. Well, if we have a number 2/3, if we times it by 1, we better get 2/3 back. But let's pick a different one. So if we times it by 7 over 7, we already know how to multiply fractions. 2 times 7 is 14 over 21st. Oh my word, look at that. 2/3 has to be the exact same thing because we times by, that's not a 7, that is a, let's draw that guy in here. That's a 1. So we just multiplied by 1, so 2/3 gives us 14 over 21. So this can work, we could have picked anything over itself, 5 over 5, 10 over 10. So we could be 10 over 15 for 2/3. Let me see if we times by 4 and 4, that's 8 over 12. 200 over 300. And there we go. We have a bunch of different names. This is what I would call complexifying, because as we know, simplifying, you take a number like 14 over 21 and say, ooh, shoot, this thing, we could turn this down into something that's a little simpler to work with. Yeah, there's a 7 that goes into both of those, so we would divide by 7, and look, all we did was divide by the number 1 to get the exact same thing, but it looks a little bit simpler. Well, why do we simplify? Various reasons, but the first one is for communication. If you went out and bought a Hershey's bag of chips, chocolate chips or Nestle or anything like that, and you have chocolate chips right here, and on the back of the bag, back there, it said, add into your recipe 7296 cup of sugar. Are you kidding? I don't even know what a 96 cup of sugar looks like. That's teeny, that's itty bitty, and 72 of them? How boring, how tiresome. Nobody talks to you when you say that. When you say you go into a party and you're like, I'm 21 years old, and you say, I'm actually 42 halves years old. You're right, but nobody talks like that. That's why we simplify things back. Sometimes it'll be necessary to take this and expand it out to many different names. Other times, most of the time, we want it simplified. When you go from a smaller one to a bigger one, it's called complexifying. And I made that up. The real term is creating alternate equivalent fractions with alternate denominators. Creating equivalent fractions with alternate denominators. I call it complexifying. And if you go backwards, you take that guy out, that is where we get simplifying. So, we've got those two things. Let's take this one, 7296, and look at, there are 3 different ways to simplify. 72 over 96. You could look at those things and say, hey, I happen to realize that those are both multiples of 24, and then divide 24 out of both of those. Not everybody can see that. I certainly couldn't have seen that, so I would have done something that I call chunks. So first one, you can just observe. And notice that's what we did right here. We just saw that they were both 7 multiplication tables. That's the first way to simplify. The second way is to do it by chunks. You look at this and you're like, 72 over 96. What does go into both of those? Oh, I know. 8 goes into both of those. So you divide by 8, and you get 9 over 12. But then you have to do it again. So I call this one chunks. So you do it piece at a time. Now you take out a 3 and you take out a 3 and you get 3/4. Ta-da! That's it. Now let's do it again another way. So that's chunks, or you could do it simply by observation. There's a third way, and this is that prime factorization. This is when you split open the number and see what it's made of. So let's do that and see what happens. Let's take 72 and split him open. It's made up of, that's 8 times 9, which is 2 times 4, which is 2 times 2, and that's 3 times 3. So 72 is 2 times 2 times 2 times 3 times 3. Okay, now let's look and see what 96 is. It splits up into 12 and 8, and 2 and 6, and 2 and 3, and that guy's 2 and 4, and 2 and 2. So we get, oh boy, that looks like 1, 2, 3, 4, 5 2s and 1 3. Now once you've done this, this is why prime factorization is handy. You can actually see everything that was complexified into this number. This guy right here, that guy is a 1. There's a 1, and there's a 1, and there's a 1. But when you multiply by 1 or divide by 1, they can just go away. That's what canceling really is. And then that 3 right over there. So we're left with 3/4. So those are the different ways to simplify. You can do it by simple observation, you can do it by pieces, or you can do it by prime factorization. Simplification pulls it down to the simplest form so you can communicate with everybody, because every single fraction can be complexified into a billion different numbers. All you do is times top and bottom by the same thing, and you can get any version of that number you want.